Okay, let's do it. So we're going to talk about polygons for a little while. And this first little section here explains what a polygon is and what it is not. So it tells you that a polygon is a closed plane figure with at least 3 sides that are segments. And then it says that there's no curves allowed and sides cannot crisscross. So if you look at these first 3 pictures, this first one here is the only polygon that we have. Mickey, hush it. This one is not a polygon because it's not a closed plane figure, and this one's not a polygon because it has sides that crisscross. Okay, in this little box, it tells us that if I want to name a polygon, that I start at any vertex, and then I list the vertex consecutively, either in a clockwise or a counterclockwise direction. So, what could I call this polygon right here? Polygon A, B, C, D, E. As long as you either go consecutively clockwise or counterclockwise, it doesn't matter. And it doesn't matter where you start. You don't have to start with the A. So A, B, C, D, E. Okay, do you know what the vertices are? Yeah, A, B, C, D, E. A is a vertice, B is, C is, D is, E is. When I list these, I'm going to put commas between them. So wherever 2 segments come together, that's the vertex that they come together, and then because we have several of them, the plural form is vertices. Okay, and sides, what would you call this side right here? AB. Side AB. Okay, what other sides do we have? AE. AE. What'd you say? ED. ED. DC. DC. And CB. Beautiful. Okay, and then how about the angles? And we could just use one letter. What would this angle right here be? Yes, angle A, angle B, angle C, angle D, angle E. And of course, we could use 3 letters to describe the angles, but in this picture, it'd be okay to just use the 1 letter because angle C is only this angle right here. It's not anything else. Okay, and then this chart of names should look somewhat familiar to you. A few of them you may not know, but a 3-sided figure is a triangle. Hopefully everybody knows that. A 4-sided figure is your quadrilateral. 5 sides is a pentagon. 6 sides is a hexagon. This one you may not know. 7 sides is called a heptagon. Did you know that?
Yes.
Beautiful. 8 sides is an octagon. What about 9 sides being a nonagon? Did you know that one?
Yes.
Okay. 10 sides a decagon?
Yes.
Okay. 12 sides a dodecagon?
Yes.
Okay.
11-agon.
I just don't think it has a special name.
It's 11-agon.
And then anything over the 12, then you typically just call it a polygon with however many sides, like a polygon with 14 sides, a polygon with 16 sides.
16 gone.
Yeah, so they don't have like a special name. It's just like a polygon with 18 sides or whatever. Okay, a regular polygon. These are your really, really pretty shapes. And the reason they're pretty is because they're both equilateral and equiangular, which means all their sides are the same length and all their angles are the same measure. So that's what regular polygons are. They're the really pretty ones. Okay, convex and concave. This first picture here is an example of a convex polygon. No matter what diagonal you draw, it never goes outside of the polygon. So that's what makes something considered to be convex. Whereas a concave polygon, if you can draw a diagonal that ever goes outside of the picture, that makes a concave picture. So this guy is concave and this guy is convex. You see the difference between the two? Okay, moving on. So now I want to practice our vocabulary a little bit. Autumn, Mickey, enough. And Mickey.
I didn't say anything.
She was talking to you and you were actively listening.
Look at my paper.
Okay, number 1 here. I want to decide if the polygon is regular or irregular. And regular means that all sides are the same length and all angles are the same measure. Let's do that part first. What do you think about number 1? Is it regular or irregular?
Regular.
Are all sides the same length? Nope, so it is irregular. So in order to be regular, all sides have to be the same length and all angles have to be the same measure. Okay, then I want to name it by how many sides it has. How many sides does it have? 4. So what would you name it? A quadrilateral. And then I want to decide if it is concave or convex. And what do you think?
I think it's concave.
Should we look at the concave, convex pictures again? Concave is when it like caves in. Concave is like if it caves in. If you can draw a diagonal and it goes outside of the picture. So concave is like if it caves in. Convex is when it doesn't. So what is this? Convex. Okay, number 2. First I want to decide if it's regular or irregular. Does it look like all the sides are the same length? Does it look like all the angles are the same measure? Yeah, and I know that because they all have one curve. So it is regular. How many sides does that have? 6, so what do we call it? A hexagon. Beautiful. And would you call it convex or concave? Convex. Okay, looking over at number 3. Does that look like it's regular or irregular? Do all sides look the same length? Well, according to the tick marks. Does it look like all sides are the same length according to tick marks? All sides have one tick mark, so all sides are congruent. Now, let's look at the angles for a second. Does it look like all angles are congruent? Okay, it shows that this angle, this angle, this angle, and this angle are all the same. But are those all the angles that there are in this shape?
No.
Isn't this right here an angle?
Yeah.
Is this angle the same measure as those guys?
No.
No. And is that angle right there the same measure as those guys?
No.
So this is irregular. So you have to think about this angle going on right there, which is not the same as all those others. So that's why it is irregular. Okay. How many sides does this one have? 8. So what would we call it? An octagon. And it is concave. Yes, it caves in. I can draw a diagonal that goes outside of the picture. Okay, and number 4. Does it look like it's regular or irregular? Regular. All sides are the same length. All angles are the same measure, so it is regular. How many sides does this one have? 5. And so what would we call it? A pentagon. And is it concave or convex? Convex. Okay. That was easy peasy, right? I think you're going to think today's lesson is real easy. Okay, the next example, we want to decide if it's a polygon, and then if it is a polygon, we're going to name it by how many sides it has. So, would you say that number 1 is a polygon?
Yes.
Yes. And what would you name it?
A hexagon.
A hexagon. It's got 6 sides. Beautiful. What about number 2? Would you name that a polygon?
Yes.
It is. And how many sides does it have?
It's a heptagon.
Because it has how many sides?
7.
7 sides. A heptagon. And what about number 3?
No.
No. Because it's got a curve. No curves. Okay. So now we're going to get into a formula. But it's a really easy formula to use. This little 1 is hidden, but there's a 180 here. This is the formula I want to use if I want to know what the angles inside of a shape add to be. So this is the formula for the sum. And I'm going to write this because you're going to see this some other places. And I didn't title it here. This is the formula for the sum of the interior angles. And it's called the polygon angle sum theorem, but you're going to see these words So I want to make sure that you're familiar with that. This is the formula that will give us the sum of the interior angles. What does interior mean? Inside of a shape. So this will give me what all the angles inside of a shape add to be. So like if I have a triangle, what do you know about the three angles inside? What do those three angles all add to be? 180. Well, if you didn't know that all the angles added to be 180, you could use this formula, and N simply stands for how many sides it has. So how many sides does a triangle have? 3. So that's why you see a 3 where the N is, and then 3 minus 2 makes 1, and 1 times 180 makes 180. So if you didn't know what the angles inside added to be, this is the formula that you would use to figure it out. Okay, so looking at number 1, I know you know the answer to this, but I want to go ahead and work it out anyway. What are the sum of the interior angles of a quadrilateral? 360. Your four angles inside of a quadrilateral add to be 360. But now I want to use the formula just in case you didn't know. So N is how many sides it has. How many sides does a quadrilateral have? 4. So I would take 4 minus 2 and take that times 180. And then what's 4 minus 2?
That's 2.
2, and 2 times 180 makes
360.
360. So if you didn't know, that's the formula that gets it done. Now this one I wouldn't expect you to know. How many sides does a nonagon have?
9.
9. So I'm going to follow the formula, n minus 2 times 180. And what will I put into the n? 9. So it's going to be 9 minus 2, and then I'm going to take that times 180. 9 minus 2 is 7. And then can someone tell me what 7 times 180 gives you?
1,260.
Beautiful. 1,260. Austin, are you trying to prove to me that you are paying attention?
No.
Okay. All right, everybody take a second and do number 3. So first you have to know how many sides a dodecagon has. And then once you know, I'm not supposed to blurt it out, Craig. And then I'm going to draw a stick. Already?
Yeah, let's go.
It's easy.
Are you a professor?
I could be.
You can be. Are you saying you have no feet or no rhythm?
No, I'm pretty talented musically. I can play the piano and the trumpet.
Piano's harder than trumpet. Wow.
It is. No, keep it. Don't lose it, because at some point I'll ask for it back. Okay, Shelby, you're my winner. What'd you get for the interior angles of a dodecagon? Yeah, the final answer. 1,800. And then how many sides does it have? 12. So 12 minus 2 times 180, and yes, that makes 1,800. Everybody okay with that? Okay, so now I need to use that formula in order to figure these problems out. And if you don't need to use the formula because you already know, that's fine. On number 1, how many sides does our shape have? 4. So what do you know all these angles add to be? 360. And then I'm going to add the ones they give me, and I'm going to subtract that from my 360. What do you get when you add those three angles up? 255. 255. And what do you get when you subtract? 105. And that's what angle X would be. So like on this one, I didn't have to bother using the formula because I just know a four-sided figure that angles add to be 360. Okay, so very much what we were doing when we were working with triangles a long time ago. Okay, number 2, how many sides does this shape have?
7.
It has 7. So first I need to know what all the angles inside add to be. So I'm going to use my formula, n minus 2 times 180. What's going to go into the n? So it's going to be 7 minus 2 times 180. Just give me that final answer.
It's 900.
Okay, so that's what all the angles inside add to be. So I do have to know the sum of all the interior angles, and then I'm going to add up the ones they give me. Calculators are kind of handy today, even though I tried to make nice numbers.
The end result is 120.
Okay, the end result's 120. Does anybody know what you get when you add those?
780.
780. And yes, the end result is 120. Boop, 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 boop. Easy enough? Okay. why don't we move on to number 4? Heather, where did you stick those extra packets? Oh, okay. Would you mind getting one for him for me? Thank you. Okay, let's move on to number 4. Number 4 is slightly different. How many sides does number 4 have? 5. So I need to figure out what my 5-sided figure's interior angles add to be. So we're going to go 5 minus 2 times 180. And what's that?
So 5 minus 2.
540. Okay. So this one, I'm going to have more of an equation going on because you see more than one x in here. So I'm just going to start combining like terms. So here's an x and here's an x. What would you get if you added the x and the x? 2x. But then I'm going to start adding all my constants. What do you get if you add the 5 to the 106 to the 94 to the 135? 340. And those should add to be what? 540. Because that's what all your interior angles add to be. So, subtract 340. I don't want to show it. What do you get when you subtract 340? 200. And what do you get when you divide? 100. Okay, you take a second and do number 5 for me, and then I will draw a stick.
Did you say number 5 or number
5. Nah, just x. Okay, Tommy, what'd you get? 60. What do your 4 angles add to be? 6x, and those should add to be how much in degrees? 360, and that does make your 60. Okay, looking at number 6, this takes us back to some previous stuff. What do you know about the 100 and the y? Yeah, those two make up a straight line, so they're supplementary. They're a linear pair. So y would be what? 80 degrees. And then from there I can find x. Because inside of this shape, what should these angles add to be? 360. And then I can subtract the 3 that I know. I can subtract the 80, the 110, and 80 added up. What do you get when you add those 3 up? 270. And if you subtract, you get 90. And there's x. Okay, so those are all interior angles. And that formula, the n minus 2 times 180, found the sum of all the interior angles. So now I want to talk about exterior for a second. What is exterior?
Angles on the outside.
Angles on the outside. So I just want to show you why it says what it says in that box right there. What would you know x to be if x and this 60 are on this straight line? X would be what? Not one. Well, the two together add up to be 180, so x would be 120. What would your y be? 120, because those add to be 180. And z is 120. So if I wanted to know what the sum of my exterior angles is, what do you get if you add 120, 120, and 120? Okay, I could do this with any shape out there, but that's what they always add to be. Your exterior angles always add to be 360 no matter what. Tristan, can you tell me what I just said?
What angles add up to be 360 no matter what?
What angles do? No. Why don't you look at something I circled in purple? The exterior exterior angles always add to be 360, whereas interior angles, it depends on how many sides the shape has, and you have to actually use the formula. But no matter what the shape is, the exterior angles will always, always, always add to be 360. So in picture number 2, what will X, Y, Z, and T add to be? 360. I don't even need to know anything else. These are exterior angles, and I know my exterior angles always add to be 360. Okay, this next box. I'm going to show you method 1, but method 2 is the one I prefer because I think it's easier, and I think you will too. Everybody looking?
Yeah.
Autumn? And Autumn? Okay, this gives me the sum of all the interior angles. If I wanted to know just one, does it make sense that you would divide by how many sides the shape has? It doesn't make sense? Okay, so if this is the formula for how you find what all of the interior angles add to be, and you only wanted to know one, then you could divide by however many sides the shape has. And then I can go from there. However, I'm going to focus more on method 2. But I did want you to notice, by looking at this picture, do you agree that your interior angle and your exterior angle, that those two always add to be 180? The interior and the exterior, those two always add to be 180? So if I ever know what the interior angle happens to be, if I want to know what the exterior angle is, I just take 180 minus whatever I know the interior to be. Okay, that's one way of figuring out one interior and one exterior. Not the sum of all of them, but just one. Okay, the other method is, if I know all exterior angles add to be 360 and I want to know just one exterior, I can just divide by however many sides the shape has. And then once I know the exterior angle, I can find the interior by taking 180 minus that answer. Which method looks easier, 1 or 2?
2.
Okay, so if you like method 1, do method 1. I'm going to do method 2 because I think it is slightly easier. So, flipping the page. It says, find the measure of an interior and an exterior angle of a regular octagon. So does that mean the sum of all of them or just one?
One.
Just one. Okay, so I'm going to go with method 2, where you find the exterior angle first, and that's by taking the sum of all the exterior angles, which is 360, and divide by n, the number of sides that the shape has. So we're talking about an octagon. How many sides does that shape have? 8. So I would take 360 and I would divide it by 8. And can somebody kindly tell me what you get? What? 45. So that would be one exterior angle. I know all the exterior angles add to be 360, but one exterior angle would be 45. And this is because the shape is a regular shape, so all 8 angles would be 45 degrees. Okay, if I want to find the interior angle, do you remember what we do? Yeah, I take 180 minus the answer I just got, which was 45. And what do you get if you take 180 minus 45? Thank you, Craig. 135. What happened to my calculators that were in the back? By? Okay. Does anybody by chance want me to do this with method 1 where you find the n minus 2 times 180 divide by n? You did it. Does anybody want to see it where I do it the other method? Nobody? Okay. So on number 2, I'm going to do the same thing. I'm going to find one interior and one exterior angle of a regular 15-gon. By the way, you can't do this if it's not a regular shape, because it's the regular shapes where all the angles are the same. So if it's not a regular shape, you couldn't do this. So if I want to find the one exterior angle, I take what they all add to be. What do they all add to be? 360, and I divide by how many sides? How many sides does this shape have? 15, because it's a regular 15-gon. And what do you get? 24. So that's what the one exterior angle would add to be, or sorry, that's what the one exterior angle would be. And then what do you do to find the interior? You take 180 minus the answer you just got. So I'll take 180 minus my 24, and what does that give me? 156. Okay, you do number 3, and I will draw 2 sticks. One for the interior answer and one for the exterior answer. Are we all glad it's Friday, by the way? Yay! We're going to do it on Monday. For some reason, I left it off in the notes, and so we're going to do whiteboards on Monday, and I'm going to stick it in there. Yes, on Monday. We'll see what they do. I enjoyed the donuts yesterday. Thank you. It was very sweet of you. And the napkins, Alex.
Did your daughter like
You still have plenty of
I forgot to even show them to her. I'll have to show. Yeah, I still have quite a few. I mean, you did use a lot, but
I did use a lot of them, not all of
It
them.
just made me laugh because let's get it started.
Are you ready?
I went to Buffalo Wild Wings.
Okay, Gavin, you're my first stick. Did you find the interior or the exterior first? You found the interior first? What did you find your... Can everybody listen? Because I'm having a hard time hearing Gavin. What did you find your interior angle to be? 120. Okay, and so then Emily Gray, that leaves the exterior. And what did you find your exterior angle to be? 60. Anybody need me to go over that? Okay, I only want to do one more problem, and then I'm going to let you guys have your assignment and get it done. Okay, moving down to number 2. Any ideas how I might approach number 2? Mickey, go for it.
You take all of the exterior, add them all up, and it equals 60, or 360.
Yeah, I'm going to take all my exterior angles and I'm going to add them up and set them equal to 360 because all exterior angles add to be 360. Okay, let's just combine like terms in our heads. What do you get when you combine the z's? 3z, and what do you get when you combine the constants? Minus 3. All right, let's solve. What would you do? Add the 3, you're going to get 363. What do you get when you divide? Not 119.
118.
121. It should be 121. Okay, that's z. Now, I'm interested in x, y, and w also. So, let's plug this 121 in right here. If this little angle right here is 121 degrees, how would you figure out what x is? Take 180 minus 121, which produces what? 59? Craig, you are my human calculator today. Okay, if I plug 121 into this z, what's 121 plus 10? Okay, so if this little angle right here is 131, what would y be? 49. Okay, and take a moment and find w for me, and I'll draw another stick. Does that mean you're not going to do it?
I've already got it done.
Oh, good.
Do you want to see my paper?
No. Savannah, what'd you get?
You just write an answer on her paper, so...
72, are you sure?
Yeah.
Well, when we plug the 121 into the z, what's 121 minus 13? 108. And so what is it? Okay. I just wanted to see if you were confident in your answer. Do you see how quickly you were to try to change?
You're a turd.
I'm not a turd. How rude. How rude.
It's because you sounded like it was wrong.
I know. Sorry. Sorry, Savannah. I apologize. Okay, so this little guy right here is your assignment. So see what you can get done so you don't have that much to do over the weekend. I know it seems like a lot of problems, but they go really quickly. You saw how quickly they go. So this is your assignment, page 5 and page 6. I will probably send you a text about it over the weekend.
What was that?
Hey, Autumn, did I give you my number so I can text you?